Hello everyone, this is the second lecture of the data science series using Python. In that lecture, the topic is data preparation. We turn to the data preparation phase, where the data are the cleaned and the prepared for the analysis. A complete guide to data preparation would require much more space than we have here. The reader is encouraged to sim data mining and the predictive analysis for the much more on the data preparation. For every dataset has its own required data prep task. In this chapter, we will focus on the following data preparation tasks. The first is adding an index field, second is changing misleading field value, third is the re-expressing categorical data as a numeric, fourth is the standardizing the numeric field, fifth is the identifying the outliers. So let's start. First is the adding and the index field. We need to open the required package using the code discussed in the previous chapter. First of all, import pandas as PD. Next, import the dataset under the name by using the read CSV command and specifying the file location. As discussed in the previous chapter, since the read.csv command is in the pandas package, we need to give the name of the package before the command. As we open the pandas package as pd, the fully command is pd.readcsv. To create the index, we first need to find the number of the records and the columns in the dataset. Using .shape after the name of the dataset will give us the number of the rows and the columns in a dataset. The first number in the output is the number of records, the second number is the number of variables. Once we know the number of records, we create a new variable that assigns the every records a unique integer. The second topic is how to change the misleading field value using RPython. Changing misleading field value in the dataset is the part of the data cleaning process, ensuring that the data is the accurate, consistent, and meaningful for the analysis. Misleading value can arise from the various sources such as incorrect data entry, outliers, missing values, or the discrepancy due to the formatting issue. Both R and Python offer powerful libraries for detecting and correcting these misleading values. Steps to change the misleading field value. First is the identification of the misleading value, second the correction of the misleading value, and third is the validation of the changes. So let's see the example of the both. First is the adding the index and the field of the data frame. First of all, import panda as the pd. This is the data. Let's run this code. This is the output of the code. Next, second is the changing the misleading field value. First of all, imports panda as the pd. This is the data for the name and age, and let's run this code. This is the output of this code: name, age, and the index. So the third topic is how to re-express categorical field value using RPython. Re-expressing categorical field value refer to the modifying, converting, or standardizing the value in the categorical column of a dataset. This can be useful for the several reasons, including simplifying categories, correcting inconsistencies, or preparing the data for the modeling. In both R and R Python, there are the multiple techniques to achieve this, such as the remaining recording and transforming categorical value. Steps. First, the renaming categories. Second is the using factor levels. Third is the combining categories, and fourth is the changing categories based on their condition. The next topic is how to standardize numeric field using RPython. Standardization scale numeric field through a common range, typically with a mean of a 0 and a standard deviation of 1. This ensures that the variables with the different unit of the range and the comparable, which is the critical for the algorithm like clustering or regression. Next is how to identify the outliers using RPython. Outliers are the extreme data point that deviated significantly from the majority of the data identifying them. After using statistical methods like the interqualities range IQR is the essential to decide whether they should be treated, removed, or analyzed separately to prevent skew result. Let's see the example of the both. Identifying outliers. First of all, imports pandas as PD, the numpy as NP. These are the data. In this example, calculate the Z zeros and identify the outliers where the zero scores is greater than 3 or less than 3. Let's see the output. The output show in the screen. And the next is the standardized numeric Python. Standardized numeric field. First of all, import pandas as PD from sklearn.preprocessing. Import standard scale. These are the data. Let's run this code. These are the output of this